Hi everyone. Today let's look at another LeetCode problem, which is problem 33. Search in rotated sorted array. There is an integer array nums. So sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index k, where k is between 1 to nums length, such that the resulting array is nums k plus 1, till nums n minus 1, nums 0, nums 1, then until nums k minus 1, 0 index. For example, 0, 1, 2, 4, 5, 6, 7 might be rotated at pivot 3 and becomes 4, 5, 6, 7, 0, 1, 2. Given the array nums after the possible rotation and an integer and an integer target, return the index of target if it is in nums or -1 if it is not in nums. You must write an algorithm with O log and runtime complexity. Okay, let me read the problem to see if I have any questions. We have an integer array nums, all of which are distinct values. The array is then rotated at an unknown index k, such that the resulting array is shifted to the right. Oh, wait 1 second. Okay, so it's rotated in such a way that the numbers are shifted to the left by k times. Right. So in here we see when we have 0, 1, 2, 4, 5, 6, 7, we shift it to the left 3 times. 0, we end up at the index 4, at the index 4. Okay, so we would like to get the index of target if it is in nums, or -1 if it is not in nums. Alright, I think the problem is clear to me. I'm just thinking about relevant informations. But what else could be relevant to know? So I would like to clarify a few things. Let's see. So clarify what is length of nums. So here it is given that the length of nums is between 1 to 5,000. Okay. So we have 5,000 elements and we need to write an overlap and runtime complexity. I think off the top of my head, what we could do is we could first search the index of the beginning of the array and also the index of the target. But what could we do it after we get the, because I'm thinking that if we need to get the index of target at the original nums, then we need to have a sorted array and then we could then find out the position in the original one. Otherwise, if it is just a jumbled up nums, then it's hard to tell the index of the target. So let's see. If we firstly we could do a binary search to find the start of the original nums, and then we could do another binary search to find the target. So this would be 2 times log n algorithm, because the first log n times the first log n complexity comes from the finding the head of the original nums, and then another log n is for binary search for the target. Okay, I think it's time to look at some example first. So for example, in here we have nums equals 4, 5, 6, 7, 0, 1, 2, and the target is 0. So here we return 0. Is that right? No, output is 4. Hold on. Okay, so I got it. Okay, so it's not about finding the index in the original nums that is not rotated yet, but it is finding the target in the given nums. Okay, I think that makes things a bit clearer. Okay, so I think in the interview it's better to go through some examples before we come up with an idea. So that's what I skip in here. But anyway, let's go through another example. 4, 5, 6, 7, 0, 1, 2. Target is 3. The output is -1 before we don't find anything. We don't find it in the nums. Third example, we have 1. Target is 1. No, target is 0. Now we return -1 is 1. Okay, so how do we do this problem? Okay, I think I got some idea. So What we need to do is we could use a binary search algorithm. The problem is how do we apply the binary search? So in binary search, we are expecting the left pointer is less than the mid pointer, the mid value, and then the mid value is less than the rightmost value. So we need to define the mid as the middle value between left and right. And after we do that, we would have, and once we know the mid value, we have three possibilities. One is the left is less than mid and mid is less than right. Now the second one is if it is shifted, then it's possible that the left is less than mid, but the mid is greater than the right. Okay. So how are we gonna do this? So let me just write down the conditions here. Conditions. 1. Left, mid, and right. Then we continue do a binary search as usual. Then we consider whether it is between the left or right. The left to end or the mid to right. Okay. Or we could also return n if it matches the value. Now second one is left is less than mid, but mid is larger than right. In this case, how are we gonna do this? Let me just write a more proper conditionals over here. So in the first case, we have left target median mid. Then we go to search the left to mid. If the target equals mid, then we return mid. If the target is between mid and the right, then we search the mid to right. Okay. But in the second case where the left is less than mid, then there are two cases. Actually, there are three the same, but anyway, if less than target than mid, then we search the left hand side. If the target equals mid, then return mid. Otherwise, if target the mid is less than target, or target is less than the right or equal, then we search the right hand side. Now the third one, we could have left is less than mid, greater than mid, and then the mid is less than right. So again, in the first cases, if the target is greater than left, or target is less than the mid, then we choose the left hand side. Or target equals mid, a return m. Otherwise, if it is between the middle and right, then we search the right hand side. I think this makes sense. Now we know when to go for when we are given the rotated sorted array. Then does this sound reasonable to you? I am pretty good about this. May I proceed to programming? Okay. Okay, so how are we gonna turn this into a code? Let me write this on this new page here. So what I'm gonna do is I'm gonna use a recursion. So we given search num comma target. Then I'm going to create mid equals length of num divided by 2. Then what you're gonna do, okay, so I think it's just a bunch of if else here. Let me see if I can do this in a better way. So in the first case, okay, so in any case, if the mid is, oh wait, 1 second. So we still need to return the index. Right, I think I need to use a while loop instead of recursion. Okay, anyway, so let's create a mid that is set to nums, length of nums divided by 2. Then what I'm gonna do is I will need a left and right pointer. The left initialized to 0, the right is initialized to length of nums minus 1. Then what I'm gonna do is I will use a while loop while nums of mid is not equal to target and the left is less than right. So let me just use n instead of mid. Okay, so what do we do now? Okay, I got it. So so what we have is okay, let's do this. So if we check the nums of left is less than num of mid less than num of right, then we search the left hand side. I mean, okay, there is an important step here. If the mid if the num of mids is target, return n because we have found the solution. And if nums of left less than target less than num of mid, then we set the left and then we set the right. The right we set it to mid minus 1 and then the left hand side thing we can stick to the same one. But now we need to compute the mid. Now the mid becomes actually we can do the mid at the end. Yeah. And with nums of mid less than t less than or equal to nums of right, then the left hand side is ignored. Okay, now this is the interesting part, which is if nouns of left now if the second and third aleph is not entered, then it would be the case where there is a yield value, meaning that so let's see which of this has been satisfied. So the p equals m is satisfied by the first if. Okay. Now the first aleph or the second condition, this will satisfy where the left hand side is sorted, and we are gonna check the left hand side. Okay, so 2 has satisfied this. Two and 3, or it is the right hand side is sorted. So 3, 2, 3. Okay, now the case where the array is not sorted well, or so if we look at condition 2, this is the example where we need to decide whether to go to the first left or the second left. The first half of the second half, yes. So how do we know that? Well, we need to check nums of m is less than nums of target. If the mid, okay, let me repeat this. If the mid is less than target, or the target is less than or equals to right, then in this case the mid, the left would be mid plus 1, and if the left is less than target, or it's a the target is less than the mid. Hold on a second. Okay, I think this should be right. Let's see. Then in here we would set the right hand side to mid -1. Okay. Now let's look at some of the examples. Number 1, we have 4, 5, 6, 7, 0, 1, 2. The nums is 7. Alright, let me quickly walk through the code to make sure I haven't missed anything. First, I'm gonna create the mid, initialize it to the middle value of nums. The left is pointing at the first element, first index, and then the right pointer is pointing at the last index. I'm gonna create a while loop so that I keep track of the index that I'm looking for. While now the mid value is not the same as target and left is less than right, then I'm gonna keep doing this until at the end I return -1. And then I'm gonna check if, wait, well, the first one is not needed at all. I'm gonna delete that. So the second if target is between left and mid, then we search the left half. However, it is between the mid and the right, we search for the second half. However, if the nums is greater than the mid or is less than the right hand side, then we're gonna choose to the right hand side. Otherwise, if the left value is less than target and the target is less than the mid value. So in this case, we explore the first half. So some examples here. We have 4, 5, 6, 0, 1, 2. Now, first of all, the midpoint at 7. Our target is 0. Okay. Now we see that this one goes to condition number 4. Yes, number 4, where left is pointing at the mid +1. Okay, so we forget to set the mid value at the end. So put it here. Mid is the mid is right minus L plus 1 divided by 2. Let's see what we got here. 0, 1, 2, 3, 4. 4 plus 6 is 10. Then we get 5. 0, 1, 2, 3. 0, 1, 2, 3, 4, 5. So left, mid, right. Then we see that the mid, okay, in this case it is sorted. So what do we do here? We move the right to mid minus 1, which in this case the mid would be 1. Then we see that it is actually at the end the left mid right will meet at 0. So we just return M. Okay, so I think I will keep the first condition so that M can return. And then don't need that. Otherwise, instead I can check the end, return M if nums of mid equals. Else minus 1. Okay, let's look at the second example there. Hold on. Yeah, I think I need to keep the first. Keep, keep. If nums of mid is the target, then just return the right bit. Okay, so in the second one, we have 4, 5, 6, 7, 0, 1, 2, left, mid, and then right target is 3. Now we don't have 3, but we do know we need to search on the right hand side. So left, mid, right. Now what do we get here? It's none of the condition. But is it? Nums of L less than target is not right. Mid is greater than target. Target, no, still no. The left one is less than target. Target is less than mid. Is that it also? No, I think I need to put an else. Return minus 1 over there. Okay, it's a bit messy. If return is 0, then just put an else return 0. Okay, we return -1 because there is no solution. Now the third one we have 1. Obviously mid is the same character. I think the while condition can check while left is less than or equal to the right side. Okay, cool. I think this should work. Okay, what else do I need to check? Yeah, I think this should work pretty well. Hold on, what if there is 2 elements? Okay, let's start on the edge case. If we have 1 and target is 0, then what will happen here? I will return -1 because it doesn't satisfy any of the conditions. How about we have 1 and 2, target is 0. This case mid will be here. Sorry, length of 2 is 2 divided by 1, mid will be here. Left and right. So 0 is between, okay, 0 is not found. -1. Our target is 3. Then -1. Hold on. 0. No, it's not greater than the right hand side. From the mid, is it less than mid and greater than that? No. If it is 3, then it end up in the same. If it is 1, then the left is it greater than left? Yes, so mid is moved to 1, and then we got the answer. Two is also the same. Now 6 test case we have 2, 1. Target is 0. What does it return? Okay, this is not sorted, so it's either the second or third condition. And the fourth or fifth condition. In the fourth one we have has to be greater than the mid value, which is not less than mid value, correct? But is it less than the mid? True. So we will explore the left hand side. Okay, this would be not fun. If t is 1, then it will return 1. If it is 2, it return 2. See, because if it is 2, then it will go to mid. We'll move it there. Okay. If it is 3, then minus 1. Yeah. So I think it should work. Let me try to put it into our LeetCode solutions. So here we have mid equals length of nums length of nums divided by 2. Then we have left and right initialize to 0 and length nums minus 1. Then the while loop is gonna check whether the left is we will check whether left is still less than or equal to right. Then we will check the mids first. Nums of m equals to target, then return m, and if nums of l is less than target, less than mid. In this case, the right will move to the mid minus 1, and if nums of mid is less than target, then less than equal to nums of right. Okay, then in this case, it will move the mid in the left to mid plus 1. With nums of left is less than equal to target, or the target is less than the mid. Now in here, we will move the left to mid plus 1. It will be much easier to understand if I put the L here. Nums of left. 1 second. Okay, this is not right. Okay, this should be the right. Oh, sorry. The right is left. Sorry, right is mid minus 1. And with nums of mid greater than less than target, or target is less than nums of right. In this case, the left will adjust to mid plus 1, else we return -1. Then if it still doesn't return, then we return -1 by force. Let's try to run it. We got time limit. See it? How is that possible? Let's see. While left is less than or equal to right, nums of mid. Okay, so we never adjust the mid value. So the mid is left plus right. Is it +1 again? I don't think so. This is just directly divided by 2. Wrong answer. Target 0, output -1. Interesting. Expected 4. And then we return. Let's see, do we need to... What is the mid value there? Mid value has to be between left and right. Okay. Let's see what we got here every time we enter the loop. Print nums of left to right +1. So initially we have 4, 5, 6, 0, 1, 2, which is our input. And then 7 is not right. Well then, it is not between 4 to 7. Okay, something is wrong. Okay, so this one here should be equals. It's still wrong. So let's see what happened here. Nums of mid is... Okay, let's print the mid here. Print nums of mid. Seven, and then let's see where we go from here. Target is not between left and right. Yes, we don't go there. Target is between mid and right. No. Target is larger than left. Also no. Target is greater than left. No. Target is less than middle. Which is... Okay, so... Alright. So I know one condition that we missed. One thing that we need to check is that I think there is no choice but to put in our conditions. So this one here, has to be accompanied with an end where the left hold on. Okay, so nums of left has to be greater than nums of the mid. Okay, so same as the one here. We missed another condition where it has to satisfy where the where basically this is meaning that the start of the original sorted array is between the is in the right hand side. The second half of it. So what we need to check is nums of n is, let's see, greater than nums of the right one. And okay, let's see, this should be correct. Yep. Now let's try to submit it. Hopefully I got it right this time. Yep, we got it right. See some solution here. It's pretty interesting, I guess. A target in num. Okay, this is not O and not N. Okay, let's look at some solutions there. This one is pretty long. I guess we got it right. It's just that in my solutions I break down everything. I break down everything and then put all of the conditions into one line. I don't have nested if else inside. I just pull it out and then make it all into one statement. Yeah, I guess I will stop here. Thank you.